Hi, today we're going to be learning how to do calculations with numbers that are written in scientific notation. We're going to start off by looking at multiplication and division. In order to multiply and divide numbers that are written in scientific notation, you need to first multiply or divide the numbers, and when I say the numbers, I mean not the powers of 10, together, okay? Then once you've multiplied or divided the numbers, you then need to go and deal with the powers of 10 and multiply or divide them together. And when you do that, you use the laws of exponents. So what you already know about multiplying or dividing numbers that have the same base or powers that have the same base, you're going to apply those laws when you're doing this. And then once you've done both of those, multiplying or dividing the numbers, and then multiplying or dividing the powers of 10, you then need to go and make sure that your answer is written properly in scientific notation. Okay, so let's have a look at an example. In this example, we've got 1.2 times 10 to the power of 5 multiplied by 9 times 10 to the power of 8. Okay, so let's have a look at how we would do this question. Okay, so here I've got my question, and like I said, the first thing we're going to do is we're going to multiply the numbers together that aren't powers of 10. So let's see what they are. So I've got over here 1.2 and I've got 9. So those are what I'm going to multiply together first. Now I'm going to write them grouped like that, but you don't have to actually write it like that. You can just do it straight away, but this will just help to see what is going on. So I've got 1.2 times 9, and those I'm grouping together. Then I'm also going to be multiplying my powers of 10 together, so I'm going to group those together afterwards. Now remember, multiplication is commutative. That means that we can rearrange them, which is what I'm doing over here, and we can also, it's associative, which means we can also group them in different ways. So that's why I can choose to do the 1.2 times 9 together, and I can choose to do the 10 to the power of 5 times 10 to the power of 8 together. I'm grouping them in ways that will work for me because I can do that with multiplication. Okay, so now let's go and work out 1.2 times 9. Now remember, when we're multiplying decimal fractions, we ignore the decimal points and any extra zeros, and we just multiply the numbers. So I've got over here 12 times 9. Now you should know that 12 times 9 is 108. Okay, now because over here I had one decimal place, that means that my product needs to have one decimal place as well. So my comma, or my decimal point, is going to go in front of the 8 over there. So 1.2 times 9 is equal to 10.8. Okay, now we're going to go and multiply our powers of 10. This is still times over here. And then 10 to the power of 5 times 10 to the power of 8. We know that our law for multiplying powers with the same base is that we add the exponents. So it's going to be 10 to the power of 5 plus 8, which is 13. Okay, so now I have got something that looks kind of like scientific notation. I need to now check that it is actually properly in scientific notation. So to do that, I need to check, remember, the number that we are multiplying by a power of 10 has to be something that is between 1 and 10, but it can't be equal or more than 10. Over here, this is more than 10. I cannot have something that is this big over here when I'm writing scientific notation. I need to change this. So that means that my comma needs to always be, remember when we're writing scientific notation, the comma or the decimal point needs to always be after the first non-zero digit in your number. So over here, the first non-zero digit is this 1. So the comma needs to go after the 1. So that should be 1.08. Now, when you are changing your numbers like this to put it into proper scientific notation, I want you to just quickly take a look at this. If I give you something that looks like this, if I have 2 million, okay, that is the same as 2 million times 1. Now, if I take this and I change this to 200,000 times 10, it's still the same. If I write 20,000, then I have to multiply it by 100 to keep it the same. If I write 2,000, I have to multiply it by 1,000 to still keep it equal to 2 million. As this one goes down, that one goes up by a decimal point, okay, or by a decimal place. So as I divide this by 10, that one has to be multiplied by 10. So over here, this is the concept I'm going to be using here. If this is going to be divided by 10 to get that, then that has to be multiplied by 10 to keep it equal. Okay, it has to stay equal because I'm saying that this is equal to that. So if I divide this by 10 to get that, then I have to multiply that by 10 to keep it equal. Okay, so as the one goes down, the other one has to go up. If this one is getting smaller, that one has to get bigger. So when I multiply 10 to the power of 13 by another 10, it becomes 10 to the power of 14. So as this one goes down, that one goes up. Okay, so that's how we correct our scientific notation. We make sure that it is still in proper scientific notation. Okay, so that's the first example. Now we're going to have a look at an example. We're going to be doing division. So in this example, we've got 5.6 times 10 to the power of negative 4 divided by, in brackets, 8 times 10 to the power of negative 7. Okay, so let's have a look at how we'll do this question. Okay, so we're going to start off by, first of all, I want you to be aware that when you've got division of something that's in brackets like this, it means, remember, this is saying that I'm dividing by everything that's in those brackets. So this is the same as 5.6 times 10 to the power of negative 4 divided by 8 and also divided by 10 to the power of negative 7. Now, I could have actually written this as a fraction like this. I could have said 5.6 times 10 to the power of negative 4 divided by this whole thing, which is 8 times 10 to the power of negative 7. So that's another way of writing it, is to write it as a fraction. Now, it's not necessary to write it like that, and I actually want you to get used to seeing it like this because we're going to be working with the numbers together, we're going to be working with the powers of 10 together, and it's not necessary to actually change it into a fraction form and then change it back to a non-fraction form again. So I'm going to keep it like this, but I just want you to be aware that it could be written as a fraction. So we are dividing by the 8, and we're also dividing by the 10 to the power of negative 7, which is why I'm writing it like this. I'm dividing by the 8, and I'm also dividing by the 10 to the power of negative 7. Okay, so now I'm going to go and do my numbers together. So I've got 5.6 that I'm dividing by the 8. And then I've got times 10 to the power of negative 4, which I'm going to be dividing by the 10 to the power of negative 7. Now remember, if we were doing it in the fraction over here, I would be able to do it grouped like that. I'd be able to say, I'm dividing those, and I'm going to simplify those, and I'm going to simplify those because they have the same base. Okay, so I'm not doing anything that I'm not allowed to do. I'm just writing it a little bit differently. Okay, so over here, 5.6 divided by 8. Remember, when we are dividing with decimal fractions, we have to make sure that the number we're dividing by is a whole number. In this case, it is, so I don't have to do anything to change anything here. And then I'm going to go and work out what this is. So I've got over here 8 that I'm dividing into 5.6. 8 doesn't go into 5, so I get 0 and then my point. And then this 5 is carried as a remainder, so 8 goes into 56 7 times. So that gives me 0.7. So 5.6 divided by 8 is 0.7. And then I have times. Now over here, this is going to be a little bit more tricky because I've got negatives. So it's 10 to the power of negative 4 divided by, or 10 to the power of negative 4 divided by 10 to the power of negative 7. Now, you need to remember that when you are dividing powers of the same base, our rule is the base stays the same, so that's why that's still 10, and then we subtract the exponent. So let's have a look at what's going to happen with our exponents over here. So this exponent is negative 4, and then we just subtract this exponent, which is negative 7. Now what happens when you subtract a negative number? Okay, so I've got negative 4 minus negative 7. When we subtract a negative number, that ends up changing to a plus. So it's negative 4 plus 7. Okay, so you can show this over here. This is 10 to the power of negative 4 minus negative 7, which changes to 10 to the power of negative 4 plus 7, which then gives us 0.7 times 10 to the power of 3, because this equals 3 over here. Or you can work it out straight away by saying negative 4 minus negative 7 is going to be negative 4 plus 7, which gives us 3. So you can go straight from there to there, but make sure that you are doing your subtracting of negative numbers properly and you're not getting confused along the way. If you are getting confused, then show your working, or actually do the working physically some way. Okay. And then now we have to go and check. Is this in proper scientific notation? So 0.7 times 10 to the power of 3. Is that written in scientific notation properly? Now remember, the number that we're multiplying by a power of 10 has to be between 1 and 10. 0.7 is not between 1 and 10. It is too small. So what I need to do is I need to multiply this by 10 to make it 7. But remember what I said in the previous example, if this one goes down, that one goes up. Or if this one goes up, that one must go down. So over here, this one from 0.7 to 7 is increasing. I'm multiplying by 10. That means I need to divide the 10 to the power of 3 by 10. I need to do the opposite. So if this was 10 to the power of 3, and if I divide it by 10, then my exponent is going to go down by 1. So it's going to be 10 to the power of 2. So that gives you 7 times 10 to the power of 2. So now I'm going to give you a few that you're going to do for yourself. Here's the first one. In this question, you've got 2 times 10 to the power of 6 multiplied by 4 times 10 to the power of 7. I'm going to give you 30 seconds to do this one. Okay, so let's go through that and see what you should have got. So, first of all, we need to make sure that we do the numbers together. So I've got my 2 and I've got my 4, which are not powers of 10. So those I'm going to group together. So that gives me 2 times 4. And then I'm going to multiply by the powers of 10. And I'm multiplying those together. So 10 to the power of 6 and 10 to the power of 7. So times 10 to the power of 6 times 10 to the power of 7. Okay, so now we're going to multiply our numbers together. So 2 times 4 is 8. Nothing special to do there. And then multiplying our powers of 10. Remember, when we multiply powers with the same base, the base stays the same, so it's still going to be 10, and we add the exponent. So 6 plus 7 is 13. So that gives us 8 times 10 to the power of 13. And if you check it, this is already in proper scientific notation because this number over here is between 1 and 10. Okay, right, let's go on to question B. In this one, we've got 6.1 times 10 to the power of negative 9 times 3 times 10 to the power of 5. Okay, so I'm going to give you 1 minute for this question. Okay, so let's go through that question and see what you should have got. So over here, I've got my 6.1 times 10 to the power of negative 9 times 3 times 10 to the power of 5. So first, my numbers are the 6.1 and the 3. I'm going to be doing those together. So 6.1 times 3 multiplied by, and then over here, I've got my 10 to the power of negative 9 and my 10 to the power of 5. Those are my powers of 10 that I need to multiply together. So 10 to the power of negative 9 times 10 to the power of 5. Okay, so now let's go and multiply the 6.1 times 3. Okay, so first of all, remember when we're multiplying decimal fractions, we ignore the comma or the decimal point. So it's going to be 61 times 3 that I'm working out. So 3 times 1 is 3, and 3 times 6 is 18. So that gives me 183. Then I have one decimal place over there. There's no decimal places there. So my product over here needs to have one decimal place. So it's going to go, the comma is going to go before the 3 over there. So this is going to be 18.3. And then over here, I'm going to be multiplying my powers of 10. So I have times 10 to the power of, now when we're multiplying, we're going to be adding the exponent. So it's negative 9 plus 5. Negative 9 plus 5 is equal to negative 4. Right, so once we've done the multiplication, we then need to go and check that this is written properly in scientific notation. Now in this one over here, it's not, because if you look at the 18.3 is not between 1 and 9, or between 1 and 10, it is more than 10. So I need to change this, and I need to make it smaller by moving the decimal point so that it is after the 1. It needs to be after the first non-zero digit. So that's going to be 1,83. But because I made this one smaller by dividing by 10, I need to do this one, the opposite here. So I'm going to be multiplying by 10. So when I multiply by 10, because this is a negative exponent, it's going to increase and it's going to change to 10 to the power of negative 3. You need to be careful when you've got a negative exponent. When you increase it, it actually looks like it's getting smaller, but it's actually getting bigger. Okay, negative 3 is greater than negative 4. Okay, so over here, 1.83 times 10 to the power of negative 3. That's what you should have got for question B. Right, let's go on to question C. You've got 7.21 times 10 to the power of negative 8 times 4 times 10 to the power of negative 3. I'm going to give you 1 minute for this one as well. Okay, so let's go through that and see what you should have got. So first of all, I've got my question over here, 7.21 times 10 to the power of negative 8 multiplied by 4 times 10 to the power of negative 3. So my numbers in this one are 7.21 and 4, and then my powers of 10 are 10 to the power of negative 8 and 10 to the power of negative 3. Okay, so I'm going to start off with my numbers. So that is 7.21 multiplied by 4. And then I'm multiplying my powers of 10 together. So it's 10 to the power of negative 8 times 10 to the power of negative 3. Okay, so now let's go and multiply 7.21 by 4. So I'm going to be multiplying 721 by 4. So 4 times 1 is 4, 4 times 2 is 8, 4 times 7 is 28. So that gives me 2,200 or 2,884. And then because this over here had 2 decimal places, and none over there, so there's 2 decimal places all together, this is going to also have 2 decimal places. So my decimal point needs to go between the 2 8s. So that gives me 28,84. Okay, times. Now I'm going to be doing my powers of 10. So 10 to the power of negative 8 times 10 to the power of negative 3 is still going to be 10, but now the exponents, because they're both negative, you need to be careful. So I'm just going to do it over here. So I've got negative 8, and I'm adding the negative 3. Now remember, when you add a negative number, it's the same, the plus and minus, they make a negative. So it's minus 3. So this is the same as negative 11. Negative 8 plus negative 3 is the same as negative 11. Okay, so that's where you should get over there. Now we need to go and check that this is written properly in scientific notation. So once again, this one you can see over here, 28.84 is not between 1 and 10. It's too big, so I need to decrease it by dividing it by 10, which means I need to do the opposite over here. So this is going to be 2,884. My decimal point needs to be after the first non-zero digit, so it needs to be after the 2, but that means that I'm dividing by 10. So over here I'm going to be multiplying by 10 to keep it equal. So over here, if I multiply this by 10, it's still going to be 10 to the power of, but the negative 11 is going to go up 1, and when we add 1 to negative 11, it becomes negative 10. So for this one, you should have got 2.884 multiplied by 10 to the power of negative 10. Okay, so that's question C. Now let's go on to question D, where you're going to be doing some division. So in question D, you've got 2.4 multiplied by 10 to the power of 5 divided by, in brackets, 6 times 10 to the power of 5. Okay, so I'm going to give you 1 minute for this one as well. Okay, so let's go through that question and see what you should have got. So here I've got my question, 2.4 times 10 to the power of 5 divided by, in brackets, 6 times 10 to the power of 5. Okay, so remember the first thing we're going to do is we're going to rewrite this as 2.4 times 10 to the power of 5 and then divided by the 6 and also divided by the 10 to the power of 5. Okay, now you could have done this writing it as a fraction if you wanted to by writing it like this, 2.4 times 10 to the power of 5 over 6 times 10 to the power of 5, and that would be fine as well. So if you chose to do it that way, it's fine. Okay, so let's go and have a look at how we would now simplify this. So I'm going to go and group the things the way that I need them. So I'm going to have 2.4, and then I'm going to group that with a divided by 6. Okay, so I'm grouping this together with that. And then over here, I'm going to be putting the times 10 to the power of 5 together with the divided by 10 to the power of 5. Okay, so now I need to go and simplify the division of my numbers, the 2.4 divided by 6. So the 6 is already a whole number, so I don't need to do any changing of anything there. I can just go and work it out. So 6 divides into 2.4. It doesn't go into the 2, so I get a 0 there, then there's my decimal point, but the 2 becomes a remainder, they're giving me 24. So 6 goes into 24 4 times, so I get 0.4. So if I divide 2.4 by 6, I will end up with 0.4. Okay, so that's what I get for that. Now, let's go and have a look at this over here. Remember, when we multiply powers with the same base, we keep the base the same, so it's times 10. And then, because I'm dividing, I'm going to be subtracting the exponents. So I'm going to have 5 minus 5, and that gives me 0. Okay. Now, the next thing I need to do is I need to check if this is written properly in scientific notation. If it was written properly in scientific notation, then anything with a power of 0 is 1, which means that this would just be 0.4. But because 0.4 is not between 1 and 10, it is too small, I need to multiply it by 10, making it 4. Okay, so I'm moving my decimal point that way and making it 4. Because I'm multiplying by 10, I need to divide this by 10. So that's going to become 10 to the power of, and then when I divide by 10, I'm going to be subtracting 1 from my exponent. So 0 minus 1 gives me negative 1. So that's 4 times 10 to the power of negative 1. Okay, so that's what you should have got for question D. Now we're going to go on to the last question before we go on to addition and subtraction, and that is question E. Over here you've got 3.5 times 10 to the power of 2 divided by 5 times 10 to the power of negative 6 in brackets. Okay, so I'm going to give you 1 minute for this one as well. Okay, so let's go through that question. So over here, once again, we're doing division like we were in the last one. So I'm going to rewrite this as 3.5 times 10 to the power of 2 divided by 5. And I'm also dividing by the 10 to the power of negative 6. Okay, now I'm going to rearrange them and put my numbers together and my powers of 10 together. So I've got 3.5 divided by 5. And I've got times 10 to the power of 2 divided by 10 to the power of negative 6. Okay, so over here, 3.5 divided by 5, and then times 10 to the power of 2 divided by 10 to the power of negative 6. Okay, so now I'm going to go and work this out. 3.5 divided by 5. Okay, once again, that is already a whole number, so I don't need to do anything special to it. I can just go straight ahead and do my division. So I've got 5 divides into 3.5. It doesn't go into 3, so I get a 0 here, and then it's my decimal point. Then the 3 becomes a remainder over there, so it's 35. 5 goes into 35 7 times. So this is 0.7. So 3.5 divided by 5 is 0.7. Then over here, I've got times 10 to the power of 2 divided by 10 to the power of negative 6 is 10 to the power of, and now because we're dividing, we need to subtract the exponents. So 2 minus negative 6. Now remember, when you subtract a negative number, it's 2 minus negative 6. The 2 minuses become a plus, so it becomes 2 plus 6. So when I subtract negative 6 from 2, it's the same as adding 6 to 2. So that's going to be 2 plus 6, which is 8. So that's 10 to the power of 8. So that gives me 0.7 times 10 to the power of 8. Now I have to go and check if it is still in scientific notation. So over here, 0.7, that is too small. It's not between 1 and 10, so now I need to go and change it. I need to multiply that by 10, which means I need to divide this by 10. So over here, this becomes 7. And then over here, when I divide this by 10, it's going to become 10 to the power of 7. So you should have got, for that one, 7 times 10 to the power of 7. Okay, so that is how we do multiplication and division with numbers that are written in scientific notation. Now we're going to go on to addition and subtraction. Okay, so when we're adding and subtracting numbers in scientific notation, the first thing you need to do is make sure that the numbers that you're adding and subtracting have the same power of 10. Okay, so remember when you're working in algebra, this is a similar concept that you're going to be applying here to what you do with algebra, and that is that you need to have like terms. You can't add them or subtract them if they are not like terms. And in order for these to be like terms, they have to have the same power of 10. So in other words, they have to both be 10 to the power of 2, or they have to both be 10 to the power of 3, or they have to both be 10 to the power of 4. Okay, you can't have 10 to the power of 2 and 10 to the power of 4 and then try and add those. It's not going to work. Okay, so we have to make sure that they both have the same power of 10. Okay, once you've made sure of that and adjusted it if necessary, then you need to add or subtract the numbers. And the powers of 10 will not change. Just like if you're adding 2x and 3x, the numbers get added and you get 5, but the x doesn't change. It stays x. So the same thing is going to happen over here, because now we're going to be adding or subtracting like terms. So the number part of it is going to change. You're going to add or subtract those, but then the power of 10 is going to stay the same. Okay? And then once you're done, just like when we're doing multiplication and division, you need to check that your answer is written properly in scientific notation. Okay, so let's go and have a look at our first example. So in this example, we've got 5 times 10 to the power of 5 plus 9 times 10 to the power of 6. Okay, so let's go and have a look at how we would do this question. So first of all, I've got my question over here, 5 times 10 to the power of 5 plus 9 times 10 to the power of 6. Now remember I said we need to make sure that both numbers, so here is my first number written in scientific notation, here is my second number that's written in scientific notation. I need to make sure they both have the same power of 10 so that they are like terms. Now if you look over here, they do not have the same power of 10. This one is times 10 to the power of 5, and this is times 10 to the power of 6. Now that's a problem. I need to make them the same. Okay, now the way that I can make them the same is by using the same sort of concept that we used in the multiplication and division. Once we got to the end and we were checking to see if it was written properly in scientific notation, we said if we make the number bigger by multiplying by 10, we divide the power of 10 by 10 and it gets smaller, okay, and vice versa. Now we're going to be using a similar concept over here, just doing kind of the opposite way around, where we're trying to get the power of 10 to be something specific, and so we have to do something to the power of 10, and then we do the opposite to the number. Okay, so over here, there are two ways I can do it. I can either make this have the same power of 10 as that, or I can make this one have the same power of 10 as that. Now my recommendation is always to try and make it the same as the one that has the higher power of 10, because a lot of the time that'll help you to avoid then having to fix your scientific notation at the end. It won't always work, okay? There will be times when it won't work, but it will help you a lot of the time to avoid having to do that extra step of changing the scientific notation and fixing it at the end. Okay, so I'll show you both where I change them both to 10 to the power of 5, and I'll also show you where I change them both to 10 to the power of 6, and then you can see how they both work, and then it does the same thing. It's just with one of them you're going to end up having to fix it at the end. Okay, so first of all, I'm going to change them both to have 10 to the power of 6, which is the higher power of 10. Okay, like I said, I always recommend changing to the higher power of 10. So I'm going to change this one to be the same as that. So if I want this to become 10 to the power of 6, I need to multiply it by 10, which means I need to do the opposite to this. I need to divide this one by 10. So if I divide 5 by 10, I get 0.5. So this is going to be 0.5 times, and then because I divided this by 10, I can now multiply that by 10, making it 10 to the power of 6. So now it's the same as that over there. So now what I've got over here is 0.5 10 to the power of 6s, and I've got 9 10 to the power of 6s. So I want to know how many 10 to the power of 6s are there all together. So I'm going to be adding them together. So like I said, the 10 to the power of 6, the power of 10 isn't going to change. It's still going to be some 10 to the power of 6. I just need to know how many there are. So it's 0.5 plus 9. So I'm adding those together. Okay, so 0.5 plus 9 is going to be 9.5. And then that is times 10 to the power of 6. Now, if you check it, you'll see that this is between 1 and 10. So I don't need to fix my scientific notation. Now, if I had done it the other way around, where I changed the 10 to the power of 6 to be the same as the 10 to the power of 5, this is what I would have got. So this is the exact same question. I'm just going to do it the other way around. So 5 times 10 to the power of 5 plus 9 times 10 to the power of 6. So now, instead of changing this one to be the same as that, I'm going to change this one to be the same as this. So this is going to stay as it is, 5 times 10 to the power of 5. But now I'm going to have plus, and now I want to make this one the same as that. So I'm going to divide it by 10, which means I'm going to multiply this one by 10. So it's going to become 90 times 10 to the power of 5. Okay, so now I've got two 10 to the power of 5s. Okay, I've got 5 times 10 to the power of 5, and I've got 90 times 10 to the power of 5. Now I need to add them. So again, we're not going to be doing anything to the powers of 10. They're going to stay the same. I'm going to be adding the numbers. So I've got 5 and 90 that I'm adding. So 5 plus 90 is 95 times 10 to the power of 5. The 10 to the power of 5 doesn't change. But now I have to go and check it and make sure that it's written in scientific notation properly. So this is too big. Okay, it's not between 1 and 10. It's higher than 10. That means I need to divide by 10 to get this so that it is 9.5. So 9.5 is what I want. That means that I've divided this by 10, which means I have to do the opposite to that and multiply it by 10, which makes this become 10 to the power of 6, which is the same as what I got over there. But in this one, I didn't have to fix it because it was already a proper scientific notation. So that's why I said most of the time it'll help if you change it to the higher power of 10. Like I said, it won't always help. Sometimes you'll still have to fix it. And sometimes choosing the higher power of 10 will actually cause it to be the one that you have to fix. But most of the time, it'll work out this way, that when you choose the higher power of 10 and you make them both the same as the higher power of 10, then you won't have to fix it at the end. Okay, so now we're going to do a few for yourself. Here's the first one that you're going to do. You've got 7.3 times 10 to the power of 5 plus 8.2 times 10 to the power of 5. So I'm going to give you 1 minute to do this one. Okay, so let's go through that and see what you should have got. Okay, so here I've got my question. Now on this one, you were actually lucky because both of them were already the same power of 10. So you didn't have to change either of them to be the same as the other one. So you can go straight ahead to your addition. So we've got 7.3 plus 8.2. Okay, so we have to work that out. So over here, I've got 7.3 plus 8.2. 3 plus 2 is 5, and 7 plus 8 is 15. That gives me 15.5 times 10 to the power of, remember the power of 10 doesn't change, so it stays 10 to the power of 5. Okay, now I need to go and check that this is in scientific notation still. So over here, if you look 15.5, oh dear, that is too big. So we need to go and change that. We need to divide it by 10. So I'm going to divide that by 10, and it becomes 1.55. Now because I divided that by 10, I need to do the opposite to my 10 to the power of 5 and multiply it by 10, and that becomes 10 to the power of 6. So that's what you should have got for question A. Right, let's go on to question B. In question B, you've got 6.34 times 10 to the power of 4 minus 2.4 times 10 to the power of 3. And to give you 1 minute for this one as well. Okay, so let's go through that question. Okay, so here I've got my question. 6.34 times 10 to the power of 4 minus 2.4 times 10 to the power of 3. So the first thing I need to do is make sure that I have the same power of 10 for both of the numbers. So I've got 10 to the power of 4 and I've got 10 to the power of 3. I'm going to choose and make them the same as the higher one. So I'm going to make them the same as the 10 to the power of 4. So this is going to stay the same, the 6.34 times 10 to the power of 4, and then I've got minus, but now this over here I need to change. I want the 10 to the power of 3 to change to 10 to the power of 4. It means I'm going to be multiplying that by 10, and it's going to get bigger, which means that this one I need to do the opposite. I need to divide it by 10 and make it get smaller. So this is going to become 0.24 times 10 to the power of 4. Okay, so once I've done that, I can now go and do my subtraction. So this is going to be 6.34 minus 0.24. So 6.34 minus 0.24. 4 minus 4 is 0. 3 minus 2 is 1. And 6 minus 0 is 6. So that gives me 6.1. Now the reason I didn't put a 0 over there is because I don't need to, because it's after the decimal point over there. So it's 6.1. So that gives me over here 6.1, and then the times 10 to the power of 4 stays as it is. Now I check, is that in scientific notation? The 6.1 is between 1 and 10, which means that it is in scientific notation, so I'm fine. So now I can leave it like that. Right, so now we're going to go on to question C. In question C, you've got 3.4 times 10 to the power of negative 7 plus 2.5 times 10 to the power of negative 8. And to give you 1 minute for this one as well. Okay, so let's go through that question and see what you should have got. So over here, I've got 3.4 times 10 to the power of negative 7 plus 2.5 times 10 to the power of negative 8. Now with this one, you have to be careful because you've got negative exponents. You need to be careful about which one is the bigger one. Okay, so negative 7 is greater than negative 8. Okay, so that means that I'm going to be changing this to have the same power of 10 as that. So the 3.4 times 10 to the power of negative 7 isn't going to change. And then over here, I'm going to be multiplying this by 10 to change it to 10 to the power of negative 7, which means I divide this one by 10. That becomes 0.25 times 10 to the power of negative 7. Okay, so now let's go and work that out. So I've got 3.4, I'm adding, so it's 3.4 plus 0.25. That gives you 5, and then here 4 plus 2 is 6. And 3 plus 0 is 3. So that gives you 3.65 times 10 to the power of, the 10 to the power of negative 7 doesn't change. So it's 10 to the power of negative 7. And then we check it and make sure that it's still in scientific notation. The 3.65 is between 1 and 10, which means that it is properly written in scientific notation, so I don't need to change it. Right, now we're going to go on to the last question for today. In question D, we've got 1.2 times 10 to the power of negative 3 minus 8.6 times 10 to the power of negative 4. Okay, so I'm going to give you 1 minute for this question as well. Okay, so let's go through that last question and see what you should have got. So over here, I have 1.2 times 10 to the power of negative 3 minus 8.6 times 10 to the power of negative 4. So if I choose the one that has the higher power of 10, that's going to be the 10 to the power of negative 3. Negative 3 is greater than negative 4. Okay, so I'm going to be changing this one to be the same as that. So it's going to be 1.2 times 10 to the power of negative 3 minus, then this one, I'm going to multiply the 10 to the power of negative 4 by 10 to make it the same as 10 to the power of negative 3, which means I need to divide the 8.6 by 10. And that gives me 0.86 times 10 to the power of negative 3. Okay, so now I can go and do my subtraction. So if I have 1.2 minus, minus 0.86, this is 0 minus 6. I have to borrow, so that's 1, and that becomes 10. Minus 6 is 4. I borrow again, that becomes 0. This becomes 11. Minus 8 is 3. And 0 minus 0 is 0. So 0.34. Okay, so over here, I get 0.34 times 10 to the power of 10 hasn't changed, so it's times 10 to the power of negative 3. Okay, so now I need to go and check this. Now, remember I said it's not always going to save you from having to fix your scientific notation. So over here, if we check this, 0.34 is not between 1 and 10. It is too small. So I need to multiply it by 10 to change it and make it proper scientific notation. So I'm going to change this to 3.4. And then because I multiplied this by 10, I'm going to do the opposite to the 10 to the power of negative 3 and divide it by 10. So if this one gets bigger, that one's going to get smaller, and that's going to become 10 to the power of negative 4. Okay, so that's what you should have got for question D. 3.4 times 10 to the power of negative 4. And that is how we do calculations with numbers that are written in scientific notation. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.